Hello! This session is all about how to transition media gaplessly with HLS. I'm Simon, and I'm a member of the streaming media team here at Apple. Do you utilize AV Player, or would you like to offer your customers a seamless up-next style playback of HLS items in your application? Do you want to present your media with the continuity that the producer intended? Can we support our customers by providing an experience to enjoy our media for longer? If yes, then you've tuned in to the best session to learn how you can now transition HLS items gaplessly. Here's our agenda. We'll survey some of the engaging media experiences you can deliver with this new feature. I'll detail the media authoring requirements. I'll step through some playlist examples highlighting best practices, and we'll end with a demo. The benefits of transitioning between HLS-backed AV Player items in an AVQ player are straightforward. Until now, the point of transition could be a little jarring, anything from an audible glitch to a momentary visual hiccup, or even an indication of indeterminate buffering. Gapless item transitions maintain a bond that your application provides between the customer and the content. Perhaps you recall the phrase, "Don't touch that dial." You can build an episodic treatment that seamlessly transitions from the end of one episode into the start of another. Gapless transitions permit the ability to replicate the seamless track-to-track album experiences that we've all long enjoyed. When doing this, we're delivering a more correct reproduction of what may have been alive or intentionally authored. We can deliver an experience that is unbroken and uninterrupted. We can replicate linear programming. But we can also provide a dynamic and perhaps even interactive experience that takes the viewer from one task or scene and directly segues into the next. Consider a transition between a set of workouts or other instructional media. With gapless transitions, we can now, programmatically, stitch scenes of an audiovisual sequence while maintaining accurate continuity. You can add reps, or add a cooldown to the workout. We can achieve all of this while still delivering media with all the benefits of adaptive bitrate media streaming over HTTP. Of course, we use this too. New features of Apple Music deliver content via HLS and achieve a gapless transition between each song. We're very excited to bring this to our customers, and we'd like to offer this to your customers too. Let's now take a detailed look at the authoring requirements you need to incorporate to effect the same item transitions in your HLS content. By providing, in your HLS manifests, variants that offer audio format continuity between sequential items, you're enabling a gapless transition. Your content should provide variants that match the following media traits: the use of FairPlay streaming, the audio codec specified by the codecs attribute of the stream tag, and the channel count as specified by the channels attribute of the media tag. Note that if you decide to offer audio renditions at different sample rates and bit depth, you may inhibit the gapless transition. The same advice to provide a match and maintain continuity applies to these traits too. Which is to say, to achieve a gapless transition, be sure to offer equivalent audio media in each variant for consecutively enqueued items. Finally, when authoring your media, please adhere to CMAF authoring guidance. CMAF stands for Common Media Application Format. In this MPEG specification, there is a specific recommendation to use an edit list to signal the presence of priming and remainder frames. Let's now take a look at a simple example by inspecting the master variant playlist of two candidate items. In this HLS manifest, I've offered 4 audiovisual variants, a pair of 720p variants, and a pair of 1080p variants. Within each pair, I offer a variant encoded with the High Efficiency Advanced Audio Codec, HEAAC, and another with AAC Low Complexity, or AAC-LC. In this example, consider the playback conditions support the selection of the 720p video, paired with HEAAC. As playback nears the end, the AVQ player will, at least initially, select the similarly encoded variant offered in the subsequent item. This is true even if network conditions now support a higher quality tier. Servicing the gapless transition is a higher priority than choosing a high quality when transitioning gaplessly. As playback proceeds, the adaptive bitrate heuristics are evaluated, and if the conditions persist, the player will seamlessly switch to that higher quality. Fantastic! Now suppose we didn't offer HEAAC in item 2. In that case, the AVQ player is unable to maintain audio continuity and the gapless transition, but is free to select the most appropriate initial variant for the playback conditions. Let's say that we have authored our content to support a gapless transition. In that case, we should remind ourselves how to use an AVQ player. Here we have a short code snippet. We create 2 AV player items and enqueue them in order ahead of playback. Note that our items source from 2 different URLs. After creating our AVQ player, we can use the insertAfter method to inform the Q player of the intended sequence. All that's left is to message play. An advanced technique I'd like to share with you permits the use of a single asset. From this asset, you can instantiate multiple AV player items. We can define different in and out points on each distinct AV player item prior to enqueuing in our AVQ player. Using the AV player item seek2time method, we can define our in point. Then we can define our out point with the forward playback end time. Here's an illustration of this concept. Item 1, 2, and 3 are all sourced from the same AV asset, consisting of the same 3 scenes. They are distinct in that I have queued each with different endpoints using seek2time and defined distinct out points using forward playback end time. Now I can enqueue these 3 otherwise identical items into my AVQ player, and what I achieve is a customized dynamic sequence. Now, let's see and hear gapless transitions in action with a demo. In this demo, we will interactively stitch together 3 workout video streams. I've left the AVKit controls visible in each so that you can really see these are distinct stream resources. I'll start by showing a seamless playback of all 3, and then we'll edit the sequence interactively. In your software, you can imagine offering the same, or perhaps perform the reordering programmatically. Right, let's do a warm-up. Ready or not? Let's do a hills run. That's it, we're done. It's time for a cool down. I can break a sweat just watching that. I'm tempted to skip straight to the "that's it, we're done" and skip the hills run. There's a lot of that here in San Francisco. To do this, let's edit the order of our exercise sets. I'll move the hills exercise to the top. This allows me to just do the warm-up and then immediately and gaplessly segue into the cooldown. Then I'll start by selecting the warm-up, now in the second position as my first workout. Right, let's do a warm-up. That's it, we're done. It's time for a cool down. Let's summarize the key points that we've learnt in this session. We've learnt that to achieve gapless transitions using HLS, we must provide variants in each item that have matching audio formats. Then we saw how easy it is to instruct an AVQ player to perform the gapless transition just by enqueuing items in sequence. We have one related session where we introduce new APIs for variant discovery. You may find that session useful if your software or service cannot guarantee the items of matching audio format. I hope you've enjoyed this session and enjoy the rest of this WWDC 2021. Thank you.